Hello guys, welcome to our last week or the last topic that we're going to discuss in our online class. So the topic that you're going to discuss is about energy resources. So there are actually many types of energy resources. This is very important for humans today because without energy resources, we won't be able to have the use of computers, cell phones, or other electronic devices, or lights in our house, something like that. And industries making cell phones, etc. So, what is energy resources? It's something that can produce heat, power, move objects, and produce electricity, which is the most important one, producing electricity. Matter that stores energy is called fuel. Human energy consumption has grown steadily through human history. So before, the early humans' modest energy requirement is just for making food and a fuel for fires to cook and keep them warm. So this is a graph on the electricity consumption or energy consumption of Thailand. So as you can see, there is 44% for industries, and we have 25% for business, and residential, same 25%, and others have 4%. Two types of energy resource, which is the non-renewable energy, and we have the renewable energy. Non-renewable energy has many types, and these energy are available sources of energy with limited supplies. So if you consume all of this fuel, it will eventually be emptied or die down. So if you have heard that oil can last like a couple of years from now because people are con consuming them very fast. And these fuels are coal, crude oil, nuclear, and then natural gas. So this is actually how coal looks. And we have crude oil. So this also dig up underneath the earth. So you will actually see a video later. And we have nuclear, and we have the natural gas. So natural gas, as you can see, they are actually burning the gas. The reason for that is to avoid damaging the ozone layer. So if they will not burn the excess gas, this is actually like the excess gas of the mining for natural gas. So if they will not burn it, come up to the ozone with pure methane, which actually destroys our ozone layer. So that's why they burn the excess that they cannot actually gather. And this type of fuels are called fossil fuels. So here is a video for
Fossil fuels. Fossil fuel is a term used to describe a group of energy sources that were formed from ancient plants and organisms during the Carboniferous period approximately 360 to 286 million years ago, even before the age of dinosaurs. At that time, the land was covered with swamps filled with organisms and plants. As they died, they sank to the bottom of swamps and oceans and over millions of years started decomposing under layers of sand, clay, and other minerals. Different types of fossil fuels formed depending on the combination of organic matter, temperature, time, and pressure conditions while decomposing. There are three major types of fossil fuels: coal, oil, and natural gas. Coal was formed from ferns, plants, and trees which hardened due to pressure and heat. Oil was formed from small organisms like zooplankton and algae, where pressure caused the more complex organic matter to decompose. Natural gas was formed by the same process as oil, only it was exposed to more heat and pressure, causing it to further decompose and turn into a gaseous form. Fossil fuels are sought-after energy sources because they have a high energy density. They are the world's dominant energy source. Fossil fuels have a variety of applications from electricity production to transport fuels. They can also be used to make a variety of common products, from plastics to cosmetics to even some medicines. These resources have powered industrialization over history and continue to do so today. Fossil fuels can be an abundant and cheap, or in some cases, a scarce and expensive form of energy, depending on geographic location. For this reason, geopolitical issues arise due to scarcity caused by the natural geographic allocation of these highly valuable resources. Fossil fuels are considered non-renewable resources because they take millions of years to form, which means that once they are used, the resources will not be replenished in a human lifetime. The gradual depletion of the most accessible fossil fuel reserves have forced companies to develop technologies for extracting more challenging or unconventional reserves. In many cases, this means additional safety and environmental concerns as well as higher costs. Fossil fuels are also the largest emitters of carbon dioxide, a greenhouse gas which causes climate change. In addition, their production causes both environmental and human health issues. These concerns have triggered society to look at alternate sources of energy that are more environmentally sustainable and renewable. That's fossil fuels.
Okay, moving forward. So method in producing power from fossil fuels. So first, fuel is burned and steam is produced in a boiler. So I'm going to show you a video after this. And the steam turns the turbine, and the turbine drives the generator. And generator produces electricity. Then the electricity is distributed to homes, business, and industries. So these three main steps, as you can see here, is also common in the renewable energy. So they actually mix steam to turn the turbine, and the turbine drives the generator, which in turn the generator will produce electricity.
In a thermal power station, like the Boundary Dam power station near Estevan, coal is burned in a boiler to convert water to steam. The steam goes into a turbine which turns a shaft. This shaft is connected to a generator that makes power as it turns. A condenser converts the spent steam from the turbine back to water that is reused in the boiler. Sask Power is among the first in the world to use carbon capture and storage. We capture the carbon dioxide coming from one of our coal units, compress it, and send it.
Okay, so that's how you're going to produce power or energy for fossil fuels. It's actually the same process as every other fuels. The next is the renewable energy. So these are the energy resource that can be replenished naturally over a relatively short period of time. These are solar, and we have wind. So wind is also not limited. Water, it's like the hydropower plant we're going to show you later. Biomass, and then geothermal. So this is actually the solar plant here. And we have wind. We have the hydropower. So this part here is actually a dam, and this is where the water flows. And we have the biomass and geothermal. So methods in producing power from geothermal. So first, steam is collected from underground, and then steam turns turbine. So as you can see, it's the same process as burning fossil fuels. But in this time, we just actually collected the the steam from underground, which doesn't have a limited amount of it. The turbine drives the generator, and the generator produces electricity. Then again, electricity is distributed to homes, business, and industries.
You may have relaxed in a natural hot springs pool, or seen the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? Well, it comes from deep beneath the surface of the Earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Okay, here's how geothermal works. Heat from the Earth's crust warms water that has seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust, or plates, meet and shift. Geothermal technology is called a flash steam power plant. A pump pushes hot fluid into a tank at the surface, where it cools. As it cools, the fluid flashes, or quickly turns into vapor. The vapor then drives a turbine and powers a generator.
Okay, so it's the same procedure as you have seen earlier. So the steam is driving the turbine here, and then it is connected to a generator, which in turn the generator produces electricity. So methods in producing power from solar. So solar, you need a photovoltaic device, this one, or solar cell. So when it is exposed in the sun, the electrons in this solar cell will actually move, creating electricity. When the electrons move, electricity is created. After the electrons move, it will go to charge controller here. Then the charge controller charge the batteries that you have here, or the battery bank. Then in turn, so if you don't want to use your electricity during the day, so you can just store it. You can just cut this off. So this inverter will convert the power to AC. So usually all houses have AC power. So the power from the battery are actually DC. So you need this inverter to invert your DC power to AC so that you can actually use this power to your homes. So method in producing power from wind flows into the blades of the windmill, or they actually call it wind power, and there would be a gearbox that drives the generator, and then the generator is producing the electricity. So methods in producing power from biomass. So same method as before, you burn the biomass, then steam will drive turbine again, and then goes to generator, and then generator converts electricity. Methods in producing power from hydro. So before creating a hydropower plant, you actually need to have a dam. They will create a hole somewhere beneath the reservoir, and then flows into this canal. So this flow will help turn the turbine, and then again turns the generator, and it generates electricity, and it's being distributed. So these are the power lines. So after the water flows here, then it will just go out to the other side. So okay, so that's the end of our discussion about energy resources. So I hope you have learned something in our discussion.